Hey everyone, and welcome. Today, we are diving deep into something that's, well, absolutely fundamental to Cisco ACI, the physical policy model. We're going to break down exactly how you can take those high-level application needs and translate them all the way down to a single switch port. You'll see how you can manage hundreds or even thousands of interfaces with just a few policies. So here's what we've got on tap. We're going to start with the big picture, the ACI physical model itself. Then we'll zoom in on the key building blocks you need to know. After that, we'll explore how domains are used to connect your logical world to the physical gear. Then we'll walk through the actual configuration workflow step by step. And finally, we'll wrap up with some crucial best practices and troubleshooting tips that'll make your life so much easier. You know, if you've ever been stuck in the trenches configuring switch ports one by one, you know the pain. It's tedious, it's super easy to make a mistake, and honestly, it just doesn't scale in a modern data center. Well, the good news is, ACI has a really elegant solution to this exact problem. And that solution, that better way, is the ACI physical model. I want you to think of this model as your map to the entire fabric. It's the framework, the blueprint we use to connect our logical policies, what our applications need, to the physical hardware, and to do it in a way that's consistent and, most importantly, scalable. The name of the game here is efficiency. It's all about creating reusable policies. So instead of touching every single interface individually, we build this hierarchy of nested policies. We start at the outside with a broad switch profile that just selects which leaf switches we want to configure. From there, we drill down into an interface profile, and finally, we get to the core, the policy groups that define exactly how a port or a range of ports should behave. Okay, so let's pull back the layers on that model and look at the key pieces. We're going to start with a real heart of port configuration, the things that define what a port actually does. First up, you've got interface policy groups. The best way to think of these, they're like a recipe card for your ports. You take all the individual settings you need, things like turning on CDP, setting up an LACP port channel, locking in the speed and duplex, and you bundle them all together into one reusable template. You make it once, and you can apply it to hundreds of ports. Next up is a big one, the AAEP, or Attachable Access Entity Profile. This little object is the essential glue in our model. It's what connects the what, so the behavior we defined in our interface policy group, to the where, which is a specific domain. And that domain is what controls which VLANs are allowed on that port. We're going to talk a lot more about domains in just a minute. And this right here illustrates the entire flow perfectly. You can see how we build from the ground up. We start with those small individual policies, CDP, LASCP, you name it. Then we bundle those into a reusable policy group. That group gets linked to a domain through an AAP. An interface profile then applies that whole bundle to specific ports. And finally, a switch profile deploys that entire configuration to the actual physical switches. It's just a beautifully logical process. All right, let's talk more about domains, because this is really where the magic happens. Domains are what connect the logical world of your tenants and your application EPGs to the physical world of ports and VLANs. They are the bridge that makes all of this possible. Now, there are three main types of domains you're going to work with. First, you have physical domains. These are for your bare metal servers, where you're typically assigning VLANs statically. Then you have VMM domains. These are absolutely crucial for your virtualized environments because they integrate directly with things like vCenter to dynamically push down port groups and VLANs. And finally, you have external domains, which handle any connectivity to the world outside your ACI fabric. Okay, here are a few pro tips to keep in your back pocket. For bare metal, it's a really good practice to create one physical domain per tenant. For your VMs, a single VMM domain can often be shared across multiple tenants, which is pretty handy. And to keep things simple, you can totally associate multiple domains to a single AAP. The one thing to remember, though, is that a domain can only be tied to one VLAN pool at a time. Okay, we've seen all the building blocks. We understand the theory, but how do you actually put them all together to get an endpoint online? Let's walk through the exact step-by-step procedure to make that happen. This is your roadmap to success. You follow these 8 steps in order. The way I like to think about it is in phases. Steps 1 to 3 are your foundation. You create your domain, your VLAN pool, and your AAEP. Then steps 4 and 5 are where you define the behavior, configuring the individual policies and bundling them. And finally, steps 6 and 7 are all about deployment, applying those policies with interface and switch profiles. Follow this order and you're going to have a smooth deployment every time. Now, this is a really, really powerful concept in ACI. It's this idea of local significance. It means that VLAN 10 inside your physical domain for tenant A can be a completely different network, a different broadcast domain than VLAN 10 in your external domain for tenant B. This completely eliminates VLAN ID conflicts, which is a massive, massive win in any multi-tenant environment. All right, you've got the workflow down. Now let's talk about a few best practices that are going to save you some serious headaches later on. Following a consistent approach here makes operations and troubleshooting just so much easier. A good naming convention is your best friend in ACI, I promise you. The recommendation here is super straightforward. First, you create one switch profile for each individual leaf node and one for each VPC pair. Then you create a matching interface profile for each of those. You keep it a clean, one-to-one mapping. This makes your configuration incredibly easy to read and manage. So what's the big payoff for doing this? It's simple. When you need to troubleshoot a port on, say, Leaf 101, you know exactly where to go. You just open up the Leaf 101 interface profile, and every single port configuration for that switch is right there in one place. No more hunting around. It's a single source of truth. Let's wrap things up with a super common troubleshooting scenario. A user calls you up, and they say their host can't ping its default gateway. In a big fabric like ACI, where do you even start looking? This right here is a critical troubleshooting fact that you need to burn into your brain. In ACI, you should always be able to ping the gateway for a subnet, period. It doesn't matter what contracts are in place. If that ping is failing, I can tell you right now, your problem is not a security policy or a contract issue. So if we know it's not a contract problem, where do you look first? Think back to all those building blocks we just put together. Where could the breakdown be? The issue almost always comes down to one of two places. First, it could be a misconfiguration in the access policies, the physical model we've just been mapping out. Maybe the EPG isn't associated with the right domain, or the AAEP isn't linked correctly. Or second, if it's a VM, the problem could be on the vSwitch itself. The VM is in the wrong port group, or it has a misconfigured uplink. So, if there's one thing you take away from all of this, it's this. Getting really comfortable with these physical constructs, the policy groups, the AEPs, the domains, and how they all click together is the absolute foundation for everything you do. It's what allows you to build stable, scalable, and manageable connectivity in your ACI fabric. So we've given you the map from the highest level policy all the way down to the physical port. The last question is for you. Now that you have this blueprint, what part of your network policy are you going to build, or maybe even go back and refine first?